In this question, a cuboid is submerged in a water tank. In the first instance, it has an x by x face downwards, and the water rises to the level of the top of the cube. We're told that the cube is 10 centimetres tall, so the depth of the water here is 10. When one of the other faces, a 10 by x face, is on the base of the water tank, the depth of the water falls by 1, so it's now 9. We're asked to find the depth of the water when the cube's removed entirely. The volume of water in this tank will be the base area of the tank multiplied by the depth of water. We know that the base area is 360, so the depth is going to be whatever the volume of water is divided by 360. Let's consider what this first diagram tells us about the volume of water in the tank. We know the depth of the water, and we know the base area of the tank. However, the cuboid sitting in the tank reduces the base area of the tank which is available for water to sit on. So how much is it reducing the base area by? It's the x by x face which is sitting on the bottom of the tank, so it is reducing the area by x squared. So 360 minus x squared is the area of the base which is available for water. The depth is 10, making the volume of water 10 times 360 minus x squared. We can do basically the same thing with the second diagram, but we have to be a bit careful here. We haven't been told what x is, so how do we know that the cuboid isn't completely submerged by the water? Well, we're told that the water level drops between these two configurations. This means that less water is displaced by the cuboid in this position. If the cuboid was completely submerged, as it is in the first diagram, we would have the same amount of water displaced. So there must be some of the cuboid sticking out of the water. Okay, so in this case, the amount of the base covered by the cuboid is 10x, meaning the volume is 9, the depth of the water, times by 360 minus 10x. We now have two expressions for the volume. The amount of water in the tank hasn't changed between these two configurations, so we can set these expressions equal to each other. Doing some simplification, for instance, dividing through by 10, and expanding our brackets and rearranging, we get 0 is equal to x squared minus 9x minus 36. I can now factorize this quadratic to give that 0 is x minus 12 times x plus 3. Since one of these factors must be 0, this tells us that x is either equal to 12 or equal to minus 3. Now, x was the length of the side of a cube. In particular, it can't be negative. So the only option is that x equals 12. Great, we're working with one less variable now. Let's think about what we wanted to find out. We wanted to find the difference in these two depths, and for that we need the volume. We have lots of expressions for the volume, so I'm just going to pick one and sub x into it. So V is 9 times 360 minus 10x, but we know that x is 12. Twelve times 10 is 120. And we want to find V divided by 360. I'm going to start doing that at this point so that I don't have to multiply out my brackets. So V over 360 is 9 times, I'll do the subtraction anyway, that's 240, divided by 360. That's something which is fairly easy to start cancelling. I can cancel multiples of 10 out and multiples of 6. I've got 6 in there for 4 left, and 6, and then I've still got a multiple of 3. And a multiple of 2. There we go. So this gives us that the depth of water in the tank with no cuboid in it is 6. So to get from 9 to 6, the further drop is 3.